Welcome to your custom deep dive. Today, our mission is to explore a really fascinating micro case study about what truly controls physical growth and development.
Yeah, it's a great topic. Really shifts your perspective.
It really does. So to do this, we are looking at an excerpt from a 2026 field journal. It's titled The Aquatic Architecture of Growth.
Right.
And specifically, we're going to be unpacking a blog post by an author named Eng, which is titled Notes on Fishkeeping, Part 238.
That's the one.
But before we even touch on the aquatic side of things, I want to set up a mental scenario for you, the listener.
Oh, I love a good thought experiment. Let's hear it.
Okay, so imagine for just a moment that you are living your entire life inside a sealed room. The walls are solid concrete, the ceiling is completely fixed.
Sounds pretty claustrophobic.
Right. And common sense tells you that the sheer physical dimensions of this, like the actual square footage, are what will ultimately dictate how tall you can physically grow.
Sure, yeah. Like if the ceiling is only 4 feet high, you stay small.
Exactly. Or, if the room is a massive warehouse, you can stretch out and grow to your full potential.
That's the intuitive leap most people make.
But what if the physical walls around you barely mattered at all? What if the factor that actually dictates whether you grow into a giant or remain completely stunted is something you cannot even see?
This is where it gets interesting.
Imagine if it was simply the air quality in that room determining your physical height.
That framing really gets to the heart of what we are unpacking today. We're looking at a complete paradigm shift in how we understand the constraints of an environment.
Right.
While the source material focuses specifically on fish fry, which, for those who don't know, is just the term for newly hatched baby fish, the underlying biological principles here offer a really profound lesson.
It's way bigger than just fish.
Oh, absolutely. It's a lesson in how invisible environmental factors shape development. It really forces us to reconsider the spaces we all inhabit, the invisible forces within them, and how we might be completely misunderstanding what actually limits our own potential.
Okay, let's unpack this. Because Eng starts the post by addressing a very pervasive assumption in the fish breeding community, right?
Yeah, the conventional wisdom.
Exactly. The conventional wisdom out there is that tank size is the ultimate non-negotiable factor for fry development. I mean, the formula seems simple enough. Small tank equals small fish. Big tank equals big fish.
It feels logically sound to assume physical boundaries dictate physical size. I mean, it makes intuitive sense.
It does. But Eng argues that the real culprits behind stunted growth aren't the glass walls at all. The actual barrier is, well, poor water quality and the rapid accumulation of metabolic waste.
Right, because the visual of a small tank tricks the human eye.
Yeah.
We see the glass, but we do not see the chemistry.
We don't see what's actually in the water.
Exactly. To understand the mechanism behind Eng's argument, we really have to look at the biology of a confined aquatic system.
Okay, break that down for us.
Well, when a breeder places a large population of fry in a small container, those fry are constantly consuming food and producing waste. And that metabolic waste doesn't just sit there inertly.
It breaks down.
Right. It begins to break down biologically into highly toxic compounds. So the primary byproduct is ammonia, which is eventually converted by bacteria into nitrites and then into nitrates.
Okay, so I understand that, drinking or swimming in waste is obviously bad.
Naturally.
But how exactly does that invisible chemical process put a physical brake pedal on a fish's growth? I mean, does the fish's body just sense the pollution and decide to stop growing?
What's fascinating here is the brutal physiological toll this takes on the organism at a cellular level. Ammonia is highly caustic.
Like it burns them?
Literally, yes.
Yeah.
When it builds up in the water, usually because the breeder isn't performing regular 50% water changes, it physically burns the delicate tissues of the fish's gills.
Oh, wow. That sounds awful.
It is. The gills become inflamed and damaged, which severely impairs their ability to extract oxygen from the water and transfer it into their bloodstream.
So they are effectively suffocating even if the water looks crystal clear to the human eye.
Suffocating and expending massive amounts of energy just to keep their blood oxygenated.
All right.
The fish's body is suddenly forced into a critical evolutionary triage because every organism has a finite energy budget.
Sure. There's only so much energy to go around.
Exactly.
Yeah.
Normally, a baby fish allocates a huge portion of that energy towards cellular division, building bone density, and increasing muscle mass.
In other words, growing.
But when the environment becomes toxic, the biological cost of simply staying alive skyrockets.
So they have to redirect that energy.
Exactly. The body diverts all available energy away from growth and channels it into repairing damaged gill tissue and keeping the weakened immune system functioning.
Wow.
So growth is stunted, not because the fish bumped into a glass wall, but because there are literally 0 calories left over in the energy budget to build a larger body.
Which brings me back to the sealed room analogy, but let's make it even more grounded in a human experience.
Okay, yeah.
Think about being at a wildly overpacked, unventilated indoor concert.
Oh, I've been to a few of those.
Right. You are shoulder to shoulder with thousands of people, and after an hour you feel completely exhausted and faint.
Just drained.
Exactly. But it isn't the small square footage of the venue that's draining your energy. It is the lack of fresh air.
Yes.
It is the collective body heat. It is the exhaled carbon dioxide replacing the oxygen in the room. Your body is working overtime, sweating, and breathing heavily just to maintain your baseline equilibrium.
That is a perfect way to put it. You are physically exhausted just existing in that space.
Right. The chemical reality of the space completely overrides the physical dimensions of the space.
And the fish are experiencing that exact same physiological exhaustion, but on a permanent developmental scale.
So we've established that external metabolic waste poisons the environment and drains the energy budget.
Right.
But Ang introduces a second invisible factor that is entirely different and honestly a bit confusing at first glance.
Oh, the hormones.
Yeah. It isn't just the toxic waste that the fish are dealing with, it is their own internal biology actively working against them. Ang notes that many fish species actively release hormones and pheromones directly into the water they swim in.
The chemical messengers?
Right. And in high concentrations, like, what you would find in a densely packed small tank, these chemicals act as a natural signal to the fry. It literally commands their bodies to slow down their physical growth.
Yeah, it's wild.
And here's where it gets really interesting, but also super counterintuitive.
How so?
Well, if the biological imperative of every living thing is to grow, thrive, and reproduce, why on earth would a fish's own body release a chemical that stunts its own growth?
It seems backwards.
Right. That sounds like a glitch in their DNA.
It seems like a glitch until we view it through the lens of evolutionary survival.
Okay, tell me more.
If we connect this to the bigger picture, it is actually a brilliant, deeply ingrained survival mechanism. Imagine a scenario in the wild. A school of fish gets trapped in a small, shrinking pool of water during a severe dry season, and the rains aren't coming for months.
Right, they're stuck.
If those fish continue to grow rapidly at their normal biological pace, they're going to doom the entire population.
Because they'll just take up too much space.
More than just space. Larger bodies require significantly more oxygen, they need more food, and critically, they produce a much higher volume of metabolic waste.
Ah. So they would rapidly outgrow the carrying capacity of that tiny puddle and essentially poison themselves to death before the dry season ever ended.
Exactly. It would be exactly the opposite of a survival strategy. So by releasing these specific growth-inhibiting hormones into the water, the collected group is communicating chemically.
Wow.
The concentration of hormones in the water acts as a highly sensitive biological density sensor.
That is fascinating.
When the concentration crosses a certain threshold, it binds to receptors in the fish, signaling their endocrine systems to throttle down their metabolism. The environment is chemically commanding them to remain small so that the collective group can survive until the next rain comes to flesh out the pool and expand their habitat.
It's like a biochemical group chat.
Yes, that's exactly it.
The water itself is carrying the message. Hey everyone, it's getting really tight in here. Resources are low. Tell your bodies to hold off on puberty and growth spurts until further notice.
Right. The organism's developmental destiny isn't just a rigid set of instructions coded in its DNA.
It's adaptable.
Highly adaptable. It is a flexible blueprint that is actively, constantly negotiated with the chemical signals of its peers. The fish are reading the room, chemically speaking, and adjusting their physical development in real time to ensure maximum survivability.
The concept that our physical bodies are having a silent chemical dialogue with the environment around us is just incredible to me.
It really changes how you look at biology.
It really does. And this theoretical biology transitions beautifully into a real-world, real-time case study that Ang is actually observing in the journal right now.
Oh, right. The happy accident.
Exactly. It is a situation Aang describes as a bit of a happy accident. So
Okay.
Aang is currently raising two different populations of fry in two entirely different setups.
Good.
One population is housed in a large EPS foam container. And for anyone unfamiliar with EPS, it stands for expanded polystyrene. Think of those giant, thick styrofoam shipping coolers.
Right. The really sturdy ones.
Yeah. They are often used by breeders because they hold a massive volume of water cheaply and provide excellent temperature insulation. So this first group has plenty of physical space and a huge volume of water.
Living the dream.
Right. But the second population is in a much smaller, physically cramped container.
So based on the conventional wisdom regarding tank size, the expectation would naturally be that the fish in the large insulated EPS container would be thriving, right?
Mm.
And vastly outgrowing the fish in the smaller setup.
Exactly. But there is a twist in the physical hardware. The smaller, cramped container has a slow leak in it.
Ah,
The water level is constantly gradually dropping day by day. And because of this structural flaw, Aang has to perform regular weekly water top-ups, pouring fresh water into the small container just to keep the tank full enough for the fish to swim.
so it's getting constantly refreshed.
Yes. And here's the kicker. Aang hypothesizes that this constant influx of fresh water is actually boosting the growth of the fry in the smaller container. The constant chemical refresh seems to be entirely overriding the cramped physical space they are living in.
The mechanics behind that hypothesis align perfectly with the biology we just unpacked.
Right.
That constant dilution of the water is consistently sweeping away those invisible constraints. Every time Aang adds fresh water, the overall concentration of ammonia and nitrites drops, relieving the strain on the gills.
Oh, that makes total sense.
And simultaneously, the density of those growth-inhibiting hormones is diluted, effectively muting the chemical signal that tells the fish to stop growing.
To bring back our crowded concert analogy, that slow leak is like someone cracking open a set of double doors at the very back of the venue.
Yes.
Even though the room is still packed wall to wall with people and the square footage hasn't increased by a single inch, that constant slow trickle of fresh night air circulating through the crowd fundamentally changes the environment.
It does.
It removes the stale, heavy air and makes the cramped space entirely survivable. The physical boundaries are identical, but the internal experience of the space is transformed.
This raises an important question, however, about the scientific method and, how we interpret accidental discoveries like this one.
Oh, for sure.
What makes Aang's journal entry particularly compelling isn't just the observation of the leaky tank, but the scientific integrity demonstrated immediately afterward.
Aang's caveat is crucial here, because if I was breeding fish and saw the fry in the tiny leaky container suddenly outgrowing the ones in the giant styrofoam cooler, I would probably jump straight onto a forum and declare, "I've cracked the code. Small leaky tanks are the secret to massive growth."
Which is the exact trap of anecdotal evidence.
Right.
You see a correlation to the leaky tank and the faster growth, and the human brain desperately wants to declare causation.
We want the simple answer.
We really do. But Aang steps back and explicitly notes that a proper scientifically sound comparison cannot be made between these two tanks.
Because they aren't even the same type of fish.
Correct. The fry in the large EPS container and the fry in the small container are two entirely different fish species.
Oh, wow. Yeah, that changes things.
It changes everything. Furthermore, they're living under different environmental factors beyond just the container size and the water changes. Different species have entirely different baseline growth rates, different tolerances for ammonia, and different hormonal sensitivities.
You cannot solve an equation when every single variable is different.
Exactly. Aang recognizes that jumping to a definitive conclusion without controlling the variables is just bad science.
It really is.
It is how misinformation and confirmation bias spread rapidly through any community, whether it's fishkeeping, data analysis, or human health trends.
We see that all the time.
Acknowledging the flaws in your own observation, admitting that the differing species nullify the experiment, demonstrates exceptional critical thinking. It serves as a fantastic reminder for you, as the listener, to always interrogate the variables before declaring victory over a piece of data.
It is a great lesson in humility. But even with that rigorous scientific caveat in place, the underlying biological principle still holds up, right? The slow leak phenomenon, even as an uncontrolled observation, undeniably demonstrates the immense developmental value of constant fresh water and the removal of invisible toxins.
Right.
Which naturally leads to the final part of Aang's journal entry.
The challenge of application.
Yeah.
How does one intentionally replicate a beneficial accident?
Exactly. So what does this all mean for the actual day-to-day operations of a fish keeper? Aang starts contemplating what the ultimate optimal setup would look like. Yeah. If constant fresh water is the absolute key to unlocking maximum biological growth potential, then the logical next step is to engineer a system that guarantees it. Aang considers building an automated drip system or a continuous flow nursery for the fry.
A setup that mechanically and perfectly recreates the flow of a natural river, constantly sweeping away waste and hormones 24 hours a day, 7 days a week.
That sounds amazing.
It represents the absolute biological ideal.
It sounds perfect on paper. But then the reality check hits.
The electric bill.
Yes. Aang reveals the final decision for the setup, and it is surprisingly grounded. After weighing the options, Aang decides to stick with a more natural hobbyist setup, relying on manual water changes rather than an automated continuous flow system.
Right.
The primary reason, simply to avoid hiking up the electric bill.
And, that decision represents a profound synthesis of theoretical knowledge and practical reality.
How so?
Well, knowledge is only truly valuable when it can be applied sustainably within the actual constraints of your life. We see this tension constantly in fields like human optimization, fitness, or biohacking. A person might design the perfect morning routine, the biologically optimal diet, or a sleep environment calibrated to the exact ideal temperature and humidity.
But it's exhausting to maintain.
Exactly. If maintaining that absolute perfection requires a paralyzing amount of daily effort, costs all of your disposable income, or stresses you out to the point of exhaustion, the optimal solution has paradoxically become its own kind of toxic environment.
The pursuit of perfection becomes the very thing stunting your overall well-being.
Precisely. Aang understands that mastery isn't about achieving the biological absolute at all costs. It is about understanding the ideal, knowing that water quality and waste removal are paramount, but functioning sustainably.
Finding a balance.
Right. A natural hobbyist setup, maintained diligently with a bucket and manual labor, might not be as effortless or mathematically perfect as a continuous flow system, but it achieves the biological necessity of removing the toxins without the prohibitive financial and logistical cost.
It is the crucial difference between knowing what theoretical perfection looks like and knowing what good enough to thrive looks like.
Exactly.
Aang is choosing to be a practical participant in the ecosystem, managing the water quality effectively, but recognizing the real-world constraints of being a human being who has to pay utility bills.
And that practical approach still thoroughly respects the core revelation of the source material.
Which brings us to the ultimate takeaway for you, the listener. If there is one concept you carry forward from this custom deep dive, it should be a fundamental shift in how you view the limitations in your own life.
Right.
Physical growth, development, and progress. Whether we are talking about a tiny fish fry in a tank or, metaphorically, your own personal and professional trajectory are almost never solely determined by the physical boundaries of the space you are in.
It's so true.
It isn't just about the square footage of your office, the size of your town, or the structural limits of your current position.
Your potential is heavily, and sometimes entirely, dictated by the invisible accumulation of elements within those spaces.
The stuff you can't see.
Right. It is the metaphorical metabolic waste. The daily frictions, the minor frustrations, the toxic interactions that drain your finite energy budget just to survive them.
Yeah.
And it is the invisible biological signals from your environment, perhaps a burned-out team or a stagnant culture, subtly telling you to stay small and conserve energy. But, as the leaky tank proves, consistent fresh inputs can override those cramped conditions.
You have to identify what the invisible toxins or growth-inhibiting hormones are in your own workspace, your home, or your daily routine. Are you expending all your energy just trying to breathe in a stagnant environment?
It's a great question to ask yourself.
And more importantly, are you ensuring that you get your own regular 50% water changes? Are you finding ways to flush out the stale air, bring in fresh perspectives, and dilute the invisible constraints, even if the physical walls around you haven't changed a bit?
It is a vital maintenance strategy for any environment you wish to thrive in.
It really is. And as we wrap up this deep dive, I want to leave you with one final provocative thought to mull over.
Let's hear it.
We started by imagining you in a sealed room where the air quality dictates your height. We learned that a simple fish can chemically sense its population density and physically rewrite its own physiological blueprint, halting its growth just to ensure the survival of the group in a confined space. So it makes you wonder, if aquatic life possesses this profound, real-time adaptability, What other invisible environmental triggers might exist right now, hidden out there in the vast animal kingdom?
That's a wild thought.
Triggers that permanently and drastically alter a creature's physical development, not based on predetermined genetics, not based on the availability of food, but purely based on the invisible proximity and chemical signaling of its peers.
The architecture of life is far more responsive than we often assume.
It really makes you think. Until next time, keep exploring those invisible architectures.